Good afternoon, everyone. Thank you for joining us. My name is Cody Hefner with Cincinnati Museum Center, and I'm excited today to be joined by Dr. Chris Carr, who is a professor of geography at the University of Cincinnati. We're going to be diving into the Maya civilization today, which is a great tie into our current exhibition, Maya the Exhibition, which features 300 original artifacts from the ancient Maya civilization, all in the United States for the first time. So it's an incredible opportunity to see some of these national treasures from the nation of Guatemala and to get a better understanding of this really incredible civilization. So I would now like to introduce Dr. Chris Carr, who's going to do a much better job than I will of introducing himself. We're going to talk a little bit about his work, the work he and his colleagues are doing at the University of Cincinnati in some of these Maya archaeological sites, and just regale you with tales of archaeology and ancient civilizations today. So, Dr. Carr, tell us a little bit about yourself and the work that you've been doing.
Yeah, thanks so much, Cody. I am, as Cody mentioned, a professor at University of Cincinnati. I recently received my PhD, so this is new. I retired from a nearly 30-year career at Procter & Gamble here in town in engineering, and went back to school as my retirement project and got a PhD. And I got the PhD so I could do really cool stuff you're going to hear about today, and which you can also see at the exhibit. So this is what I do. So what do you think, Cody? Should we jump into the slideshow?
Well, in a minute, now I'm curious. What was your background at P&G, and what made you go down this path? Is this just kind of a passion project for you?
Well, at P&G, I'd always been doing volunteer vacations. I had more vacation time than my wife did, so I'm going to go off and do something else. So I volunteered on a lot of research projects, studying coral reef bleaching in the Bahamas, or the introduction of elk in the coal fields of eastern Kentucky. And I said, hey, you know what? When I retire, I want to go out and do something. I'm not just going to move to Florida and play golf. I don't actually like either of those things. So I said, okay, what can I do? Can I actually get some credentials and have people let me join their projects? So I don't have to actually pay to join their projects. They'll at least pay my way and get to go to cool places and do some environmental stuff and give back to society. So that's what I had in mind. And it's worked out.
So Rachel, I think, speaks for all of us when she says your career transition is inspiring. Growing up as a kid, I wanted to be an archaeologist. I was always fascinated by, like every little kid, with mummies. And to me, that's all archaeologists did. They dug in the desert for mummies and searched for pyramids. And I even remember in elementary school, we had to draw a picture or a book about what our life was going to be like. And there was one page where it's me holding a map and kind of the dotted line and an X, because I was going to be an archaeologist. That hasn't worked out for me, but you're telling me there's still time.
Yeah, yes, there's still time. And you know what? Some of that stuff was in the back of my mind too, as I'm saying, well, what do I do with my retirement? What do I go back to school in? And it turns out geographers can do just about anything. It fits lots of different places. So I study archaeology, mostly because the professor, Dr. Nick Dunning at University of Cincinnati that I started working with, he just worked in the Maya area. So I said, okay, I'll go along with you. And that's how I became someone who works in the Maya area. It wasn't really by choice. It was just Nick went there, so I'll go. And it's the forest, it's the jungle, and it's archaeology, and that's what is really cool to do.
Yeah, that's incredible. So I'm going to turn you over to your slides. Some of this is your work and your research that's showcased in Maya the Exhibition at Cincinnati Museum Center, that you, Nick Dunning, as you mentioned, David Lentz, and Sarah Jackson have contributed to the exhibition, which is really incredible. A lot of times when we bring exhibitions in, we like to have some sort of local component, either There's a local story aspect to it. When we had a Star Wars exhibition, we were able to tell the Kenner toy story. With this, there's not a great Maya story locally in Cincinnati, except there is, and it's the work that you all are doing at the University of Cincinnati and that you all have been doing. So with that, let's jump into your slides and you can showcase some of that for us.
Cool, thanks.
You're driving now.
Okay, let me see if I can get the full screen thing on the PowerPoint. So Cody, is that just the Maya slide?
That's it.
Okay, cool. So here is an opening slide that I always use, Temple 1 at Tikal. And as a matter of fact, the Maya exhibit, this is the opening picture of the Maya exhibit. This is the icon site for the Maya world, for the Maya in Guatemala, which is the country that sponsored this major traveling exhibit. So Temple 1 there, this is what they look like, the pyramids in the Maya area, a restored one. Most of the ones that I get to scramble around on have not yet been restored. But I have been up this one, up to the top there, this top corner here. I went up there one time when the University of Cincinnati was working there, and I wanted to measure the location of this corner and compare it to some work some people had done back in the 1920s. So that was really cool to have the opportunity to go up there.
How high is that?
It
Chris?
would be maybe 5 stories tall to get up to that ledge there. So, and this staircase, this is how you get up. The staircase in the middle is really, really steep. I have no idea how the ancient Maya rulers and priests would get up to this balcony up top with all their regalia and their headdresses and stuff. It's quite amazing. And it was really scary coming back down that stairs. It is really, really steep. Luckily, I'm a rock climber, so it was no big deal for me. But the graduate student from Guatemala who was with me was pretty freaked out. I said, you know what? You know how a baby goes down the stairs? Just kind of turn around and scooch down. And we made it back to the ground.
Good advice for everyone.
Yes. So here we are. Upper left is some of the objects that are in the exhibit, the Maya exhibit. I was actually there yesterday morning, filming some stuff. Got to see it again. The lower right is a model of Tikal. And that is the staircase of Temple 1. There's the corner where I was. So this is a great society. They obviously built really big buildings. They made really cool artifacts. They had artwork here. This was a really, really advanced society. So they were really doing things right. And the question is, what were they doing right? How did they manage particularly this climate that they have, which is rain for 5 months, and then the opposite 5 months essentially completely dry, no water. How do you manage a big city, a successful city, when it doesn't rain? I mean, we have, reservoirs is the answer. Well, we'll just jump to the answer. They developed a system of reservoirs to store the water from the rainy season and then use it in the dry season. And that's what we're really interested in the research group that I'm in at University of Cincinnati. How did the Maya manage that? How did they manage this difficult environment? And of course, you can think ahead how climate change could change our environment now, and maybe we can learn something from the ancient Maya, both about what worked well, allowed them to build these giant cities, and then what didn't work well, because these cities are all abandoned now. So it worked, and then it didn't. So what can we learn? Here's another view, some more artifacts from the exhibit in the upper left. And One of the things that I'm particularly fascinated by are these vessels here that I'm moving my cursor around. They tell stories. They're kind of like a moving picture as you spin that vessel around. So they're pictures which show some scenes. There's also writing. They annotated, they put captions on their pictures. So far, I have not found one that tells the story of an ancient Maya reservoir. I think they're probably there. I think probably my engineering counterparts have some stuff. Haven't found it yet, but I'm looking for that. On the lower right, here's another view of downtown Tikal. Pretty sure that's Temple 1 right there. And here is one of the things I'm talking about. Blue, this is a reservoir. This is Palace Reservoir because it's right next to the Royal Palace in downtown Tikal. This is a kind of reservoir that researchers have been familiar with for all the time that archaeologists have been in Tikal. It's obvious that it's there when you walk down in there. We've been down in there excavating. It's obvious this is a reservoir. It's right next to the palace. It's really obvious that this is an elite reservoir. Not everyone gets to use water out of this reservoir. And that comes to what we're interested in. What about common people? How did the common people get their water? Did they have to come and ask the king every time, or did they have their own water supply? And the answer is, we've learned, yes, they had their own water supply. So where are we? Geographer, gotta have a map. So Cincinnati here, Southwest Ohio, head on down. And there is the site that we've been working at for the last 7 years or so, Yashnuka. Just a little bit south of that is Tikal, the place I was showing you the maps of. For those of you who maybe been down to the Yucatan Peninsula, Cancun is up here. We sometimes fly in Cancun and take a long bus ride down the peninsula to our jungle camp.
It's a good way to get students to go on these spring break digs and expeditions, right? Tell them you're going to Cancun, but don't let them know that you're just hopping on a bus.
Yes. Yeah. Oh, everyone gets off the plane in Cancun. They've got their flip-flops. They're all ready to go to the beach. And they do go. We get on the bus and go the other direction into the jungle where it's hot and buggy and nowhere near the beach. Yes. So we saw some big Maya pyramids right off. Here is a commoner's house. Actually, there's probably a middle-class house compound. This is the way the ancient Maya lived. They would build buildings, typically, 4 groups of buildings, and the buildings would create this plaza in the center. And this is where the daily life of the Maya family would take place. It's hot, it's humid down there. You don't want to be cooped up in a building. So they would be out here. That's where they would live. The buildings are on a little bit of raised platforms. Remember, it's 5 months of really heavy rain. So you don't want rain going into your building, maybe where your hammock is, where you sleep at night, where you store your food. So it's elevated. A well-to-do family would eventually build walls of stone rather than just mud, and then thatched roof on top. So this is what it would have looked like 1,000 years ago, 2,000 years ago. Since the Maya have left, the buildings fall down. But they're made of stone. There's a lot of stone in there. So when they fall down, they end up looking like this. Hope you look at that and say, what is that? It's just trees and leaves and stuff. Well, this is a house mound. This up and down here and then across here. That's what one of those houses looks like when it falls down. So we'll have typically 4 of these around a plaza, and we'll come back to that. This whole, well, that's me standing up there. I've got my field notebook. There's a GPS on my backpack. So I'm recording the location of this house mound, and I'm going to compare it to the LiDAR data that we're going to look at momentarily. Another unfortunate thing is this hole here. This is a looter's hole. Looters frequently come in and poke holes in the house mounds, in the pyramids, to look for cool stuff. They're not going to find any gold, because the Maya just did not have gold until very, very late. There's just not gold in the area. So mostly it's a disappointment. A few broken pots is all they'd see.
So how do you even find this? Because we're in the rainforest, right? We're in the jungle. How do you even know where you're going? Yeah, I imagine there's not hiking trails and a map that says go this way and for a quarter mile and you're going to see a house just off to your left. How do you even find where you're going to know where to look? I mean, it's like trying to find a needle in the haystack, but you can't even find the haystack to start looking for the needle. And that has been a problem for a long, long time. The new technology of LiDAR changes that. But in the olden days, 15 years ago, you just had to wander around in the jungle if you were going into a new area. Sometimes the local people will be out there collecting sap from trees, to chicle sap, to make chewing gum, or they may be collecting leaves to send up here for flower arrangements and so on. And you may talk to them and say, hey, have you seen anything cool, any old buildings out in the jungle? And they say, yeah, sure. You want us to take you there? So that's a lot of what you have to do. Once airplanes were invented, you could fly over, and Charles Lindbergh did a lot of this, fly over, and occasionally you'll see the pyramids poking through the top of the tree canopy. So then you go to that place. But you only end up going to the really big places. You don't see the commoners' houses, and you rarely see the reservoirs because they're just hidden under the tree canopy. Here is something you might have seen when you flew over in an airplane. This is a reservoir, a very large water reservoir that's been out of service for 1,000 years, maybe longer. So you can see the dense tree canopy in the background. It is jungle. It is solid stuff. It's a challenge to walk through because there are vines everywhere. They crisscross. A lot of the vines have prickers on them. You don't want to touch them. There's one vine, Bael, that has these fine prickers on it. They almost look like just a fuzz on it. If you touch it, and I have when I first got down there, all the prickers stick to your hand. It looks like you've been shot with a porcupine. There are just hundreds of little stickers in your hand, and you just have to get out your tweezers and pull them out one by one by one. So largely you learn, don't touch anything. But that leads to another question I had, and I know it's slightly off topic, but how do you protect yourself in the jungle? You're going into a jungle. Like there's wild animals there. And how do you make sure that you're safe?
That's a challenge. Most of the people who go into the jungle go with a muchetero, a local worker, either Pepe or I forget his name, who goes ahead of you with a machete and cuts a path through the jungle for you. And you just say, hey, let's go in this direction and let's whatever. And they'll cut a path. By and large, I don't worry about the wild animals. I have had monkeys give me grief. But the jaguars, they'll run, you'll never see one. They just leave before you arrive. Snakes can be an issue. There are some really poisonous snakes. So the last couple of years, I've started wearing snake gaiters, which are foot-tall leather straps that go around your lower leg, your feet and your pants leg, so that if a snake comes at you, it will just hit that and won't be able to bite you. The wild animals that are actually far more critical are no-see-ums, no-see-um bugs. They're kind of like mosquitoes, but really, really much smaller. We have them around here. They can transmit some pretty nasty bugs to you, which I have gotten. So the real trick is lots of bug spray. Nick, it's maybe hard to tell, but his pants are tucked into his socks on his shoes. It looks really dippy, and the young grad students won't do it because it looks so dippy, but I do it. Lots of permethrin bug spray on your clothes, lots of DEET on your body. You may not like spraying your body with all these chemicals, but you know what? The bugs are a whole lot worse. So that's our main way. And, you should, good backcountry things. You should not go out in the jungle by yourself. I do, but you're not supposed to.
So you've rightly earned your nickname as the bad boy of archaeology, right? By just wandering into the jungle alone.
Yes, right. Now, I do go in with what you'll see, answering another part of your question, the modern way, the LiDAR maps. And I will typically have 3 or 4 GPS units with the LiDAR maps in them. So I don't get like totally lost, because you can't see the sun there. And so you don't know which way is which. I also carry a compass, and I also have a mental map of our entire study area. So I know if I get like totally disoriented, I know, okay, I just head in a northeast direction and I'll run into the road. So that's my main fallback. And you know what? If I'm totally lost and disoriented and it's getting dark, I'm just going to stop and lie down where I am and wait for the morning. That hasn't happened to me yet, but I'm prepared for it. By and large, other people should not go out by themselves. I have found people in the jungle, grad students wandering around quite lost and quite panicky. That's quite an experience.
No doubt, that's for sure.
Yeah. And Cody, by the way, this is great. Thank you for stopping and asking questions. And
of course.
Hopefully the viewers will also be able to type in some questions, and I can jump back and forth to them also.
Well, I do have one question from one of the viewers. Sarah asked if there's unmanned aerial system used in the aerial work. And I know you mentioned LiDAR, but I wonder if there's unmanned systems as well.
The people are starting to work with drones. It is really difficult in this area to do that. The tree canopy means when a drone with a regular camera flies over, it just sees the tops of trees. And it will see this low area here, this old water reservoir. But it won't see any of the cool stuff. So you miss out on that. There are drones that are coming along with LiDAR, a lot more expensive. They will be cool. They will work well. But the issue is, if you have your $80,000 drone, which can do all this cool stuff, how do you get it up in the air, and how do you make sure you don't lose it and have it crash into a tree? So it's coming, but it's not there yet. We basically just have to hire an airplane with a regular human pilot to fly over and collect our data. So here's a reservoir, and we'll talk, how do we find these things? And we'll get there. So here is what you would see if you fly over in a drone or an airplane, or this happens to be a satellite. This is what it looks like looking out from 200 miles up in the air. Satellite that flew over the area. And what do you see here? Well, you see a lot of green. So there's a dark green. There's some lighter greens. I don't know what color that is. Sort of a brownish color. Clouds, shadows from clouds. I hate clouds because they mess me up twice. They block the view there, and they block the view where the shadow is. This is the swampy area. We'll come to that. Let's jump. See that little spot up there? Bright green, lime green. That's what a water reservoir looks like from the air. It's just this little spot. You could easily confuse it. Let's cursor wake up again. There are other these little spots. These are not water reservoirs. These are trees, really, really big trees sticking up through. But that spot is a reservoir. That's just the algae that forms on the water. This is a big chunk of the ancient Maya city of Yashoka. There are hundreds of houses here underneath that tree canopy. There's a gigantic pyramid. There's a royal residence. There is a couple of really large reservoirs there. Right? You see it, right? No, we don't see it. No, it's not there. But
I thought it was one of those magic eyes where you just had to stare long enough until the image popped out at you.
Okay, do that. You ready? Count down. 3, 2, 1. Bingo. Magic eyes. It worked. This is the same place with all the trees removed with LiDAR. The LiDAR sends laser beams through the tree canopy, through the gaps between the leaves, and hits the ground. And then the laser pulse bounces back to the airplane. It measures how long it took to get there and come back. And that you can calculate the elevation of the ground. So that little spot we saw, it's in the middle of that. That's where that lime green spot was. This is an ancient Maya reservoir. You can see the berm all around it. Remember when we looked at those Maya houses that were in those groups of 4 around a plaza? Do you see those here? Do you see a whole bunch of them here? There's one, a group of 4. More, here's a group of 4, a bigger one. And actually some kind of blob there, something a little bit bigger. There's a couple just tagged together. So maybe this is an extended family. They built one family group and they just added onto it by this reservoir. There's a cool thing that is wild, wandering around through that thing. I spent a lot of time wandering through there. This, by the way, is Mukal Reservoir. We'll hear about Mukal again. So what have I sort of ignored? What is everybody zeroing in on in their eyes? Saying, what is that other thing?
I'm looking bottom right.
Yeah, how about that? How about that? Everybody, I'm sure you're looking at that. Yeah, I avoided it on purpose. We avoid that. That's, that's a pyramid. That's one of those things you saw like in the opening scene, Tikal, Temple 1. Yeah, this is Yashoka's, one of there's 6 of them. It is on a big platform. This hill here is really steep. It is really hard to get up and down. That's the way we get up and down. We put in a road and we can park our trucks about here. And then you go up top here. And we have excavated at the base there. How about this?
Is that another reservoir? Is that the Royal or the Palace Reservoir there?
Yep, this is another royal reservoir. Yes, this is the reservoir that's associated with, this is the Fidelia complex. So this is the Fidelia pyramid, and this is the Fidelia reservoir. We're thinking quite possibly there was a ramp. Well, there is a ramp there now, and we think maybe that ramp directs water that falls on this plaza and on the pyramid here. It directs it down into the royal reservoir. So this is an example of one of the big reservoirs. And this talk, I sometimes call it a tale of three reservoirs. So we have a big royal reservoir here, which the royal people would have control over. I mean, it's just physically close. You just see it there and say, yeah, they did that. That was it. We see it in the LiDAR. Then we have this Mukal reservoir, smaller, but still substantial. And one of the things that I find totally cool is the berm isolates it from runoff from the upland area. Let's get my cursor back again, wake up there. This is upland. I think you can see from the way this image is shaded that this is a hill and water would run down the hill here during the rainy season, but it will not, at least under normal circumstances, get into this reservoir. So this reservoir only is filled with rainwater. And that's another story that we bring up in the UC part of the Maya exhibit, that maybe runoff from the red paint here, when the red paint flakes off and runs down into the reservoir, it may poison the reservoir because the red paint contains mercury. That's where the red comes from. So this large reservoir may actually be a bit of a problem for the local people. Go ahead.
So why would they have prevented the runoff in the upper reservoir? It seems like that was deliberate, or is that just how the berm at the top was? It was just a lucky consequence, or why would they do that?
Well, that's our research. That's brand new stuff. The LiDAR is showing us that there are a lot of these reservoirs that are isolated. So we're putting that together with the findings about the cinnabar and the mercury poisoning from royal central reservoirs. We're seeing maybe it is on purpose. And to my mind, looking as a geographer, I look at where this thing is positioned, and also from my engineering background. If I'm going to design a reservoir, I mean, it means something when I put it essentially perfectly in between these two upland areas, and I put a berm all around it. That says to me, they want to isolate it. So, and we have lots and lots more examples of that kind of reservoir. This is actually in the swampy low area. That's why this ground is so smooth. This is swampy area here, which is also why there are no houses down there. It floods. But best we can tell, the water does not get into the reservoir. It's isolated. And it turns out when you work out the volume of the reservoir, which we can do with LiDAR, we weren't able to do it before LiDAR, but with LiDAR, we can work out the volume of the reservoir and say, you know what? That reservoir will fill up with rainwater in the rainy season. They don't need to collect water from anywhere else. They get enough falling out of the sky, nice clean water falling out of the sky. So that's research that's brand new. We haven't published that yet. We're just starting to put the story together for that.
You heard it here first, everyone.
You did.
It's a good thing everyone tuned in. This brings up so many questions for me, and from some of the viewers as well. One of them should be pretty easy. Rachel asked, "What's the age of this site? Is this pre-classic, classic, or post-classic? What time period are we looking at here?"
We have examples of all those eras here at Yashoka. The faculty member who runs this project, who's the principal investigator, Catherine Reese-Taylor from University of Calgary, she is most interested in pre-classic. So a lot of the excavations that she focuses on are pre-classic. This structure groups here, these four-sided plaza groups, this is more classic era stuff, but we are not the height of the classic era with grand carvings and so on, like they have up at Chichen Itza, up in the upper Yucatan Peninsula. So I would say this is largely pre-classic era here.
And then,
so go ahead.
And then two other questions. Thank you, Rachel, for that question. Sarah asks, the ramp from the temple to from the pyramid to the palace reservoir, is that kind of a gutter system?
We did some excavations right about here, and we weren't able to find anything like that. And I think what happened, we didn't think it through well enough. What's going to happen if you had a gutter system in the 1,000 years when it's not being maintained and rainwater is rushing down there? It's going to erode it all away, and all the gutter arrangement is not going to be there anymore. I'm trying to wake up my cursor. I think we should have excavated down here where all the stuff, the rock and stuff, would have ended up. So we didn't see it, but when you look at this in detail, it's very clear there was some sort of ramp that led from up here to down there. And at Tikal, there is water does run off the plazas into the palace reservoir. So we assumed it did here, but we haven't been able to verify that.
The gray lines on this map, are those added in afterwards, or?
These lines, yeah. I added these in to highlight the edge between the upland and the Bajo, and there's one around here. I think those are probably the lines they're asking about. So let's drop back. So here you go. Here's the line again. That just shows you, I did this to help my brain keep straight, just how much you just can't see. Here's the outline of the Fidelia complex, that upper area. There it is. It just, it doesn't show up. A little bit of the reservoir. You can sort of see something's different there, but without the LiDAR, you wouldn't know.
That's incredible.
So Cody, you asked earlier, how do you get around? Well, I take this image and put it on my cell phone. So I'm sure many of you use Google Maps or something to navigate when you're driving around with your car. And there's a little dot on the map that shows you where you are, and you can click on something and say, take me to there. Well, I have that same thing on my cell phone when I'm in the jungle. And when we park our truck somewhere around here, and someone says, well, back up. Before we went to Yashoka, the season where we worked in this area, Nick Dunning said, you know what, I want to excavate a medium-sized reservoir. Well, actually, he wanted to excavate a big one too. He did that one earlier year. He said, now I want to do a medium-sized one. I want to learn more about that reservoir, when it was constructed, what was the sequence of construction. So I looked through the LiDAR and found a whole bunch of different examples of things like this. And we talked through it before we went down. We said, okay, the rest of the project team is going to be working here, so we can get a ride in their truck out there every morning. So let's have this one be our example of a medium-sized reservoir. So right when we arrived at the beginning of the field season, the first day the field crew went out to here, I got out my GPS and I just started hacking through the jungle. And I went up top here, I followed along the ridge there, went down and said, I want to walk through this. Probably nobody has walked through that in hundreds, if not 1,000 years. And then I'm just going to start going out into the swamp and find this thing. So that's how we find things. And I would have had a couple of macheteros with me cutting a trail, even though I prefer to just walk in the jungle without cutting a trail. But most other people don't like to do it that way. It's too hard.
Wow.
Yeah.
That's incredible. And so it's still swampland. It's still, marsh and wet and
right.
Kind of dense to slog through, right?
Well, okay. We know about weather reports. We know about wet, dry environment. We don't go there when it's wet.
That makes sense.
if you'll remember, it's 5 months wet, 5 months dry. So what we want to do is go during that dry season. And actually, since we're all academics, it's kind of a narrow window. The faculty and grad students need to finish up like the spring semester, which is right towards the end of the dry season. So we immediately head down there to do our work. And then you're down there for maybe as long as 6 weeks, and then the rains start and you have to get out or you'll get stuck in there because we have to go through several swamps to get to this area. This swamp continues on up for 40 miles and we have to cross over an arm of the swamp to get out from our area. So, and I've never been there in the rainy season, but I've seen pictures of it. It is horrible. The bugs, we have almost no bugs in the dry season. They're all desiccated, but the bugs are horrible during the rainy season. So try to avoid it if you can.
This is insider knowledge. These are good notes.
Yeah, yes. Okay, so I've talked about LiDAR. Let's just quick little thing here. This is basically how it works for us. We don't yet have drones someday, but airplane. So the airplane has this laser, basically a laser rangefinder, and it shoots the laser beam down and measures the distance from the airplane to whatever the laser beam hits. So it'll measure the top of the trees. If the laser beam happens to go through a gap in the tree canopy, it'll measure the ground. And as the airplane's flying, this laser beam zigzags back and forth. So we get coverage on the ground. Then you do a whole bunch of processing and you can get the image that we see here. You get the elevations of all the points here, and then we can convert them into, this is called a hillshade image. So it kind of looks like a picture that you would see, but it's really all elevation data. And you can set the sun angle and all that cool stuff. So that's sort of the magic of how we do it. And it uses, the GPS satellite system. So the airplane knows where it is. So we can do all the calculations there. So uses the $1 billion satellite system. And then we have an airplane. And this is maybe 1/10 of what we have. That's on the order of $40,000 to purchase that, to have the airplane come down and fly that for us. So
oh, wow.
expensive stuff. But to map this by hand would take a long, long time. And you'll see in the exhibit some maps of Tikal where it was mapped by hand. And it took him like 4 field seasons to do an area equivalent to what we got with the LiDAR for $40,000. So having 4 field crews down for 3 or 4 months at a crack, that's going to add up. So I think LiDAR is a pretty good image, pretty good cost value.
In locally, Cincinnati Museum Center has used LiDAR as well in Newtown at the Han site, which is an early indigenous population settlement here. And certainly it's not as dense as this, but in that area, so much of that is underground, and it's remarkable to see some of the, how you can look at this and just pick out depressions in the ground and say there's something there, to know where to dig instead of just going in the middle of the field and sticking your shovel in and say, here we go. Right,
exactly, and that is what we use it for now. And a mound that you would see out there is very similar to the mound around the outside of this reservoir. If you did not have the clear area in the middle, like we saw in that one photo, you could walk over that and you wouldn't even know you're in a reservoir, or you wouldn't even know you walked over a Native American mound. You just you go up a little bit and you go down a little bit. But building on your thing, knowing where to dig. I remember I said this is a tale of 3 reservoirs. Well, I've talked about 2 of them, the big Royal Reservoir, a medium reservoir, how about that little dimple right there? What do you think about that?
I don't think much of that at all.
Right, exactly. You don't think much of that at all. And I didn't either until I wrote a computer program for the computer to go through and find all the little dimples. That's what I call them, dimples in the ground. And because maybe they are reservoirs. I was actually looking for big stuff, but it started showing me little stuff like that. That's a reservoir. That is the third type of reservoir. That is a little household reservoir. And we'll talk some more about that. And it's in the exhibit. Unfortunately, it's not on display right now, the workings of this, because it was a hands-on exhibit. And just with COVID, we can't do that at the moment. But what we think is going on here is the ancient Maya quarried rock out of, well, the capstone, the rock that's makes this upland. They quarried the rock, they built their structures. Remember, I said they're made out of rock, made out of limestone rock. And they quarried in such a way that they end up with a hole in the ground. When they've taken the rock out, you line it with plaster, and now you've got a 2-for-1 deal. I got the rock for my house, and I got the reservoir for my family. And imagine, there's one here. There's another one somewhere around in there. These are those little kind of reservoirs by houses here. Not quite as fancy houses down here at the bottom of the hill. Actually, pretty typical to what we see. The more well-to-do people live on the top of the hill. But imagine if you have that reservoir for your family here, you may not be quite as beholden to the ruler who lives here in this pyramidal structure and palace with their gigantic reservoir. So it changes the power dynamic. Again, this is brand new stuff. We're still putting this story together, but we did go out, and one of my colleagues did excavate that area. And I think I have some more. I was looking for the photo, but we're not quite there yet. So here we go again. There's the little reservoir, the household reservoir I was talking about. Where is it? It's somewhere here. I mean, you just would have no idea. You'd have no idea this house group is here. Again, Mukal Reservoir. Any other questions for now?
So not yet. I think this is a lot to process. This is incredible, and you've done such a great job in answering questions. So yeah, let's
keep going.
Let's keep going. Let's see what else comes up.
Okay. Well, look at this. So here is the excavation at that little dimple, which you would have no idea to go there, except for the LiDAR. I mean, LiDAR is my specialty. Obviously, I'm pretty excited about it. And what I do on archaeological projects is I help the archaeologists find the kinds of things they're looking for. And then they will go out there and spend several weeks. This is Dr. Jeff Brewer, one of my colleagues. He was also a graduate student of Dr. Nick Dunning. There's Nick at the bottom of the hole there. So Jeff and I, again, before we went down, said, let's look for small reservoirs. That's what Jeff is focusing on, small household level reservoirs. Nick focuses on big and medium-sized ones. So we found this depression in the ground, and Jeff started digging a hole. And every day for about 3 weeks, he would come out here with the two guys that were working with them, and they would take the dirt out of this hole. They take it out, they put it on the screen, they screen the dust through and the big chunky rocks and look for pottery, look for various chert artifacts, spear points, things like that. Look for bits of charcoal that they can use for carbon-14 dating. And they just work their way down this far. Said, you know what? That, and what Jeff is standing on there, that is the plaster floor of a reservoir.
Wow.
And Catherine Reese Taylor, our project leader, said, you know what? That's cool, but what's under the floor? And everyone looked at her. So we're not done. So they had to poke through the hole, through the floor, and they dug down some more, and they found 3 more layers of floors. So the ancient Maya started, and they would use a reservoir for a while with a floor, and maybe a couple of 100 years later, they'd come back. So it silted in, there was some junk in the way. They put in another floor and another floor. And what I think was happening, this is the part that I'm looking at, is this wall in the background. They were repeatedly quarrying this area. They started out with a narrow, deep quarry, and then after a while, they quarried again, and the rubble fell in. They built another floor, kept it that way for a couple of 100 years, maybe, and then they quarried again. Whoops, Siri is trying to wake up on my phone. Siri, go to sleep, sorry. So we think that's what's happening, why there were these multiple floors here. So every time they wanted to expand their house, they'd quarry some more and dig some more. So this is a lot of what we do. We dig holes in the ground. Go ahead.
So despite the technology of LiDAR that's helping you see through the canopy and all this other technology, GPS, you're still doing a lot of work with a shovel and some elbow grease, right?
Absolutely. You do a lot of it. And it's sort of an iterative process. We started with the LiDAR and said, hey, something interesting might be here. We excavated, we said, yes, it is interesting. This is a quarry. Then what I want to do is go back and say, well, find me all the other dimples. And do they kind of look like this one? And then I will guess that they are reservoirs, and I'll guess that they are quarries. So then what I have done is go back and hike all over this area looking, while Jeff is excavating at this little spot, and Jen is excavating up here, and Nick is excavating down here. I wander around all this area looking, saying, hey, are these similar type things, at least on the surface? So I went out into the swamp and looked at these little dimples here. They are not quarries. They are not reservoirs. I think they may be quarries for mud, for clay, but they're not rock. This is not a rocky area. So we go back and forth between the various on the ground elbow grease stuff and going out in the using the LiDAR and surface inspection.
We have a couple questions, and I don't want to jump too far ahead. I don't know if it'll come up later. So if it does, just tell me to hold up, and we will. What are the questions from Carolyn? You mentioned cinnabar and the mercury poisoning, and I know that's one of the reasons why people started to move out of the large cities. After those large cities were abandoned, where did the surviving Maya go? What happened to them?
Some of the population collapsed, and there just weren't as many of them because it just wasn't as prosperous and well-organized a society. Some of them from this area in southern Yucatan Peninsula moved more to the northern Yucatan Peninsula. And some of them just dispersed out into what is now jungle. And a lot of it we don't know yet because we haven't looked under the canopy. And again, that's where LiDAR will come in, getting looks throughout areas where there are no big pyramids, so no archaeologists have been. But maybe the Maya were living out there, so maybe we will see evidence of them out there. And the answer is yes, we do, as we've looked through some LiDAR that was actually collected for other reasons, nothing to do with archaeology. It was actually collected to look at carbon sequestration in the forest, but we realized, hey, we can look at the ground too and see what's down there. And we find evidence for lots of Maya, ancient Maya ruins throughout the Yucatan Peninsula.
Did did they know the contaminated water was causing a problem, or was it a how does that timeline go? How do they make that discovery and adapt to it?
I'm not I'm not totally convinced that they really knew. Um, it was just one more stressor on their society. If their rulers are getting mercury poisoning, it tends to make you not quite so competent in your ruling. Mad Hatter disease from Alice in Wonderland is an example of that. So they, in addition to environmental stressors on their society, there may be this chemical stressor. Again, this cinnabar thing, that's also brand new stuff. I can't remember if David is published yet on that or not, but that's only within the last year that we've realized that. David Lentz is the leader of that effort.
And so, with anything, it becomes a concentration situation. So if there's a low concentration of mercury in the water, not a problem. But if you compound that with drought and other things, so to your point, it could very well be the fact that how do they point to one thing? It's this combination of issues. And so they may say, oh, our crops aren't growing the way they're supposed to. We don't have as much water as we need to support this many people. We're going to move out. At the same time, they're being poisoned by mercury. So what is the push factor in all of that for them that may lead to that? Is that part of it?
Mm-hmm. Yeah. And I think stuff like these isolated reservoirs, medium size, I call them isolated reservoirs, or isolated from the uplands. Yeah, who knows, the royal reservoirs may kind of got a little stinky. I don't know what latrine systems the ancient Maya had, but the water could end up being kind of nasty, and your nose just tells you, no, don't use this.
Fair enough. What else you got for us? I saw there's more slides. Let's get to them.
Yeah. Let's run a few more. This is how we live. These are two particularly exciting events of the day or the week. Laundry day. This is our field camp out in the middle of nowhere. It's a 6-hour drive. If you got sick and you needed to go see a doctor, it's a 6-hour drive through the jungle to get to the doctor. So we're pretty much self-contained. So once a week we get our laundry done. So all that smelly, stinky clothes that you've been wearing as you've been hiking through the jungle gets cleaned up here. So we have a field camp. It's some formerly abandoned military garrison on the border with Guatemala. We're in Mexico. And we've been refurbishing it year by year. So we have a few buildings. The professional staff sleep in tents, and the local workers sleep in hammocks. Hammocks are a really, really sensible way to sleep in the jungle. You get lots of airflow around you. So we have the cooks and the local women. We have 5 cooks and camp people, so they'll do the laundry. They have an old-fashioned washing machine with one of those ringers on it to squeeze the water out, and then they hang our clothes up, and you go around looking for your clothes. So all the boys' underwear is back there, all the girls' underwear is over there, and whatever. So it's kind of cute what they do. This is what it looks like at the end of the day. When we hike out of the jungle, usually we're about half an hour off the road, excavating. So they're the local workers. There's one of the grad students, Thomas Rule, PhD student in geography. And you hike out your half-hour hike out to the road. The trucks are waiting there for you. And then we take our half-hour, 40-minute drive back to the field camp. So you get to sit down and you get to ride. It is kind of cool. I now know that one of the trucks has air conditioning in it. And as a senior researcher and older, I many times claim a seat inside the air conditioning truck. So that's kind of cool. A new grad student, or when I was a grad student, I knew that my job was to ride in the back of the truck. You do not get inside the truck until you have a PhD.
I think that's fair.
Yes, it's fair, right. So now I have a PhD and I can ride in the truck without feeling guilty. Some more examples of what it looks like. Our work involves a lot of, as you saw before, digging holes in the ground. So this is a hole in the ground. This is Nick Dunning. This is Nick's hole in the ground. And there's the rest of our crew looking at Nick's hole in the ground. Nick is very proud of his hole in the ground. For the rest of us, it looks like a lot of dirt, but okay, I'm starting to get into understanding what he does. He was my PhD advisor, now colleague. And behind us, this is a reservoir. This is a reservoir that holds water. That's why there's no trees in there. The trees won't grow back there. So this is the berm. And again, Nick wanted to understand the construction sequence. So he dug a hole through there. Here's another reservoir. This happens to be Mukal Reservoir. This is a hole in the ground in the center of Mukal Reservoir. So Nick is pulling up samples of the mud there. And you'll see actually there's a close-up picture in the exhibit of getting the mud out of the sampling device, putting it into a special test tube with a preservative in it. So we'll take that back to the lab and do DNA analysis on it, which is another really cool technology. We can look at what are all the plants that were in that mud, again, 1,000 years ago, when the ancient Maya were using this reservoir. What kind of things did they have there? So another really, really cool technology.
That's incredible. I would never think of DNA being used in that way.
Yeah. I mean, you've probably all heard of ancient DNA, like mummies. You started with a mummy discussion, Cody. People have done DNA analysis there to understand, bloodlines and so on. But we're using it on the plants. And that's what's cool. This is a multidisciplinary team. Nick is a geographer. I'm a geographer. David Lenz, professor of biology. He does the DNA stuff. This is one of his grad students, Mariana Vasquez. She's doing a PhD in this tropical paleoecology. A master's student from Cincinnati and one of our local workers. So it's just been great having. And then we have all the archaeologists who come along with all this stuff.
So how many of you are there on a expedition, on a trip at a time?
This field camp, which we may be in for like 6 weeks a year, we'll have maybe 10, 12 professional staff. That's archaeologists, faculty members, PhD, and then typically grad students, usually PhD students, but occasional master's students. And then we'll have a support crew of maybe 25 people, local workers, the macheteros who cut the trails, the excavators who actually dig the holes, the camp cooks. We have drivers. We have 4 or 5 trucks, so each one has a driver and assistant. Because when you drive on these roads, you have to consider that the road will be blocked by a tree. It will be every few days, so you have to stop, get out the chainsaw, cut the tree up, get it out of the way, and then you can continue on. And then we have other drivers that drive up to town maybe once a week to get water. We need potable water for camp. We have to bring that all in. We have to bring in gasoline for the generators. So it's a really big operation to do that.
Wow.
And just talk about the swamps. On the photo is what these swamps look like now in the dry season. It is just forever a tangle of stuff like that. You are climbing over those things. You're crawling under them. It is absolutely horrible to go into the swamp. And I can fully understand why, basically, until recently, well, probably I may be the only person who purposely goes into them. Nobody will go into them because it's just horrible. And I mean, like, what's there? Why go in there? It's just, you look out over it from a high level and it's just this stuff. You can see it. It's undifferentiated. It's just a tangle. And there's nothing there, right? Well, no, there is something there. And that's what we've learned with the LiDAR, with like this little spot here of McCall Reservoir. So there are things out there, and the LiDAR helps guide you out there. So it makes it worthwhile to go out there. Another really cool thing I've realized from going out there, look at the ground. It's like perfectly smooth. If someone chopped those trees and moved them out of the way, that would be gorgeous to walk through there. Really, really easy. If I wanted to get from the uplands on one side here to the uplands on the other side, nowadays, it probably makes more sense to walk all the way around because the uplands are a little more open. But the ancient Maya, you just chop a little hole through the middle there, keep a path open, and it's really, really simple. So it goes from a really horrible place to go through to a really easy place to go through. So I'm trying to put that together and thinking about how did the Maya use their space here? How did they live there? How did all these people use this environment?
Wow. That's incredible.
I think, yep, that's it. That's my slideshow. What else? Questions?
So we still have a couple questions floating over here. Sarah asked, how far is the 6-hour drive? So what's the distance you're talking from civilization to where you're out here working?
I bet it's probably 30, 40 miles. That's all.
Oh, wow. Yeah, that's...
You can walk faster than the truck can drive over the swampy area or over all the rocks to go up and down the hills.
That's incredible. Wow.
Yeah.
Rachel wants to know, where can we stay updated on your research and the developments with it and what we're learning from it?
Our basic way of getting knowledge out is publishing journal articles in the scientific literature, which is a pretty obscure way, and it's a lot of bits and pieces. We occasionally give talks like this. We don't really have a website, which would be kind of cool to do, just to put out general stuff and blogs. So probably the best method is just occasionally Google Maya and get some stuff from us and our colleagues.
And I think the other point there is, for anyone who is in college, has kids in college or friends in college or anything like that, make sure they're making use of the expertise of their professors, because this is fascinating, because your hypothesis, your guesses on why they did certain things or what this means may be true. They may not be. You may find new information and say, "Oh, that was off base,"
Right.
But it's fascinating to hear the thought process, to walk through why you think certain things, and that doesn't always make it into the finished product. The sausage making is sometimes a really fascinating part. So often you're in college and you're like, all right, well, I'm going to read this chapter. I'm going to write this paper and go on and take these notes and move on. And you're not going to office hours. You're not picking the brains. If this is something that you're interested in just from a hobby perspective and you want to know more, take advantage of those office hours. If this is something you're thinking from a career perspective, when you're in your 20s or as a second career, make use of these people and their knowledge. It's so incredible, because I get into these and I hear this information. It's so amazing, and everything you say brings up 2 or 3 other questions that's either how do you know that? How did you find that out? Or, okay, so what are you going to do with that? And it's just remarkable. Chris, this has been really incredible. The last question I want to ask you is, you've been to the exhibition now 3 times, you
Yes.
said?
Yes.
What's your favorite piece in the exhibition or aspect of the exhibition?
You mean other than the stuff that features me?
Yeah.
Yeah.
Listen, if you're not going to toot your own horn, no one's going to do it for you. So
Right.
you got to.
I mean, obviously, I'm pretty excited about the LiDAR, but you know what? In terms of advancing what I'm thinking of, for me, let's jump way back. I am really fascinated by these things here. I want to find the story my predecessor, the engineer who designed this cool stuff, what is their story? I want them to talk to me directly, and I'm hoping I will find it on one of these pieces. So yes, that was the first thing I did, was go in and stare at these things.
That's incredible. And that's what's so amazing about exhibitions like this, and the work that you're doing to reclaim these things, is to tell the stories behind them. It's not always the larger society issues and things that you're looking at. Sometimes you're just looking at the individual. What is the person who made this? What's their story? What was their life like? What can we learn from this? Or what does someone in this line of work do? And I think that's what's always really amazing, is that you look at these things and you have to realize there's a craftsman behind this who's making this, molding this clay, molding this pottery, doing the cave paintings just above those is incredible to think that there's someone behind that. And we have these stories thousands of years later. It's so incredible. So a few other comments I just want to share with you, Chris, before we head out. Sarah, she agreed. She loved the same vessels that you did because they are both decorative and practical. That's what she conjures up. That's what it makes her think about. And it makes her think about the society in terms of what they advanced. And because they had time to make beautiful things, that they weren't just so focused on surviving all the time, that they had time to be skilled craftspeople as well, which is really incredible. And Rachel has a book suggestion. She's reading Breaking the Mayan Code, that has some really interesting insights into the artists and the writers, and who they were. So sharing that with you. But otherwise, Chris, I'm going to give you the full screen here in case you want to say any parting words or anything before we sign off.
Yep, it was great. It was great talking with all of you. I liked the questions, and come down and see the exhibit and get even more. And
if you see Chris walking around in there, make sure you say hi. So I know you're visiting again soon, and it sounds like that may not be the last time for you either.
Oh, yes, I picked up something new every time I've gone through the exhibit.
Great. Well, thank you everyone for tuning in and for listening, and absolutely thank you, Chris, for sharing your information and your wisdom with us. The exhibition is going to be at Cincinnati Museum Center through January, so you still have plenty of time to see it. We're open Wednesday through Monday. Thursday through Monday. We're closed Tuesday and Wednesday, so plenty of time to come in and check that out. And as I mentioned earlier, we're really excited to showcase some of the work that the University of Cincinnati has done, including Chris, Nick Dunning, who he mentioned throughout this Q&A as well. Their work is featured in there, so make sure you come out and see it. It is really an incredible exhibition. Dr. Carr, thank you so much again, and thank you everyone for tuning in. If you missed anything, you want to watch this again, you want to share this with anyone else, we will make the video available within the next few days so that you can share that with others who can glean some new knowledge from Dr. Carr here. Thanks, everyone. Have a great rest of your day.
Thanks, everyone. Bye-bye.